Greetings and welcome to Tank Cleaning on Demand. Due to varying time zones and schedules, we recorded this training so that you may not only view when convenient for you, but review if needed. While this full presentation takes approximately 13 minutes, please note that you may view by section at your convenience, simply by clicking on the slide of choice in the left navigation. This way you may come back to the presentation at any time to view or review. You may stop or pause any slide by using the navigation bar below the slide. In addition, please note the Attachments tab in the left navigation, containing web links and PDFs that we hope you will find useful. And now, Michael O'Grady, Tank Equipment Manager, Tank Equipment Market Unit.
Thanks for taking the time to view my presentation today. For the next several minutes, I'd like to give you a brief introduction to the value provided by our tank cleaning equipment product line. Since Alpha Laval purchased the Tufte Tank Cleaning Machine Company in 2003, we've become an important source for our processors seeking to improve their tank and vessel sanitation process. Our customers have learned that through the use of efficient tank cleaning machines, they can improve sanitation, clean faster, and reduce the amount of water used to do so dramatically. And this is where our cleaning equipment could affect the sustainability goals of the processors in our markets. It is common knowledge that these processors are looking to decrease the water usage at their plants. You can visit some of their websites as confirmation of these goals. I looked recently and found most companies stating their desire to reduce water consumption at their plants by a certain percentage, usually 10 to 15%, though one large processor stated a 30% goal. Another large U.S. company targets reducing water use by 15% per pound of food produced at their facilities. Yes, the proper use of tank cleaning equipment can easily exceed these goals for their applications. So, for the next several minutes, I'd like to start out with some of the basics. We plan to discuss common cleaning preferences and methods leading into the types of spray cleaning devices. This will lead to one of the important concepts I've already alluded to, the cost savings benefits of this technology. After looking at the different types of devices, we'll then look at some typical cleaning applications, comparing the different cleaning devices and their efficiencies. Finally, we'll wrap it up with a look at the current and future tank equipment portfolio. Now, the goal for any cleaning procedure is to perform it as efficiently as possible. To that end, we're looking to clean to a high sanitary standard while using a minimum amount of water and chemicals, producing, of course, a minimum amount of waste. And ideally, we would like to be able to validate the process. Some of the common cleaning procedures used at most plants involve manual hand and brush cleaning, a method still commonly used even though there are far more efficient alternatives. A similar comment could be made about handheld high-pressure sprays, especially when looking at water consumption for that method. Fill, boil, dump, a process done by filling the entire tank with cleaning fluid and boiling to wash, also uses a lot of fluid energy to complete. We'll spend some more time on the next few methods: fixed spray balls, rotary spray balls, and rotating jet heads. Each adds an increasing level of efficiency when considering the parameters we discussed a moment ago, automating the sanitation process, using less time and fewer resources, and producing less waste. Alpha Laval offers all three of the following spray devices used for distribution of cleaning fluids. The most commonly used of these devices would be the fixed spray ball. The reason it's the most commonly used, it's the lowest priced option of the three, not, however, the most cost efficient. The two rotating devices are the rotary spray head and the rotary jet head. The fixed spray device distributes cleaning fluids through the drilled holes of the ball itself. The tank is cleaned by the continual cascade of enough hot water and chemicals so that after a length of time, the desired level of sanitation is achieved. Rotating cleaning devices add the advantage of mechanical action and a high level of impact to the process. In fact, if a change was made from a static spray ball to a rotary spray head, the cleaning process time could be reduced by at least 30% using that much less cleaning solution. A change to a rotating jet head could result in a 50% or greater reduction in time and/or cleaning solutions used. Why is a rotating device so much more efficient than the static one? Again, the effectiveness of the static spray ball relies on a high flow cascade of water and chemicals at elevated temperatures. This flow continues until the vessel is clean. This graphic shows that if some residual is adhered to the vessel wall, the fluid tends to initially fall around the soil until it's been soaked enough with solution that it eventually wears away. The next slide has a picture of a clear tank showing this exact scenario. If this picture is clear enough, you can see two low flow areas where the water cascading from a fixed spray ball is initially flowing around soiled areas. It will take additional flow of heated cleaning solution to fully clean this tank. The rotating spray head can generally clean a tank 30% more efficiently than a static spray ball. The cleaning fluid flows through the slotted ball, allowing it to rotate as it distributes cleaning solution to the tank walls. The liquid fans impact the tank wall and the solution flows down as it cleans. Pictured on the left here, by the way, is our sand midget rotary spray head, which is commonly used in dairy 3A applications and biofarm applications. Our rotary jet cleaning heads can clean some tanks up to 50% more efficiently than fixed spray balls. These devices project a jet stream of fluid to the walls of the tank in patterns. The impact effect, combined with the increased rotary action, results in a clean tank in less time using a minimum of resources. The flow of cleaning fluids through the device makes the nozzles perform a geared rotation around the vertical and horizontal axis. The nozzles move in figure-8 pattern. Subsequent cycles are each offset from the previous one, eventually resulting in the 8-cycle full pattern. Incidentally, these pictures are graphics from a software program we developed called Trax. This software can be used to simulate the performance of a tank cleaning machine in a vessel before it's installed. Now that we can see how the machine covers the tank with cleaning solution, we need to understand why impact makes a difference. Pressure is the driving force for this technology. The flow turns the cleaning machine, and fluid pressure is converted to jet velocity. Every point that the jet stream of cleaning solution hits, the green line in this depiction, forms a shear stress zone around it, shown by the blue circle here. That is the advantage of impact on cleaning. One can picture this exact scenario if you can imagine pouring water out of your garden hose on concrete. Now screw on the hand spray nozzle and spray down. You can see the direct impact and the shear zone around that point, clearing everything off your driveway. Also, this added velocity allows the cleaning machines to be more effective at large distances as well. If we go back to that scenario where some residual has attached to the tank wall, instead of relying on the continual flow of high temperature cleaning fluid, we can remove soils faster with a jet stream. Even if the stream does not directly impact the soil, the velocity in the shear zone is effective at clearing the soil off faster. Another advantage of rotating jet cleaning machines is that we now have the ability to validate the cleaning of the tank. By installing a sensor in the top of the tank, we can measure the impact of the fluid jets to verify the proper operation of the machine. A signal or alarm can be sent to the process control system if the sensor detects a non-programmed signal. The effective use of rotary cleaning machines will directly result in cost savings at the plant level. Repeatability and reduction of manual steps leads to an improved sanitation level. Reducing water and cleaning chemical consumption leads to immediate cost savings, and a reduction of cleaning time can lead to an increase in production time. And all this equates to a quick payback. And remember, we started this discussion claiming that the effective use of cleaning machines can help processors meet their sustainability goals. As it applies to cleaning more efficiently, we feel that the proper use of rotary cleaning machines will reduce manual operations, the time it takes to clean, and the amount of waste produced, as well as the amount of chemicals and water used to clean these vessels. Now let's look at some typical application scenarios that really bring into focus the equipment's effect on sustainability, specifically on fluid volumes used. To portray a generic scenario, we'll need to make some assumptions in order to show one of the key benefits to rotary cleaning machines. Again, water savings. In the next three examples, we'll clean an 8-foot by 8-foot 3,000 gallon tank which has about 251 square feet of internal surface area. In this first example, we want to employ a static spray ball. Using traditional design criteria, we could use from 0.19 for a fairly small tank to 0.5 gallons per minute per square foot of internal surface area. For this tank, that gives us a range of anywhere from about 48 to 125 gallons per minute. If we consider a 60-minute cycle cleaning, 5 days a week, 45 weeks a year with a 55% recovery of some of the cleaning and rinsing fluids, we come up with anywhere from 294,000 to 760,000 gallons of fluid required to clean the tank. Changing to a rotary spray head like our Santa Midget can result in some calculated savings in fluid used to clean this same tank. The flow rate required to clean this tank using a Santa Midget is about 30 gallons per minute. Depending on the tank and material to be cleaned, we could use anywhere from 1 to 3 devices to complete the job. With the same 60-minute cleaning scenario, once per day, 5 days per week, 45 weeks per year, we end up using anywhere from 182,000 gallons if we're using one device to 546 gallons per year. This comes to a 29 to 38% reduction in cleaning fluids annually. Finally, this example shows the result from cleaning this tank using a rotary jet head. For this size tank, only one machine is required, using 30 gallons per minute of cleaning solution. For this scenario, we'll be conservative and use a 45-minute cleaning cycle, and again once per day, 5 days per week, and 45 weeks per year at 55% solution recovery. This results in using 137,000 gallons per year. Compared to a static spray ball, we're looking at cleaning solution reductions of anywhere from 50 to 80% depending on the application. All applications are unique, of course, but here's where we can make the most dramatic impact on plant sustainability goals. So, what do these machines look like in action? And here's our TJ20G rotating jet head. Notice the fluid that appears to be leaking from around the head. This is actually the release of fluids as the machine cleans itself internally. And you can see that it does a pretty good job of cleaning the external surfaces as well. Here you'll see a rotating spray head, our Santa Midget, in action. Notice the 360-degree spray pattern, which covers the entire tank, as well as the downpipe the device is attached to. Well, as we wrap up here, I wanted to quickly describe the Alfa Laval Tank Equipment Group portfolio. Today, we are one of the market leaders providing tank accessories such as tank legs, sight glasses, as well as manways. And as we described, we are also a leading provider of tank cleaning solutions to the sanitary and process industries. We've also recently launched our patented magnetic mixer for use in tanks in the pharmaceutical industry as well as aseptic and beverage processing. In the months ahead, we plan to go to market with a new line of tank instrumentation products. That will include load cell tank weighing systems, flow transmitters, and other pressure and temperature monitoring devices. And look for the introduction of new agitation and mixing equipment in the months ahead as well. You can look forward to additional on-demand training programs as the Tank Equipment Group continues to introduce new equipment solutions to the market. Our goal is to be the first complete line supplier of tank equipment to the industry in the U.S. and abroad. Well, one quick reminder, you can review any slide by clicking in the left side navigation area. Also, we have an attachments tab with a variety of tank equipment links and downloads. Thanks a lot for your time, and feel free to call on our team for any support